Welcome to 2B notes, which is solving absolute value inequalities. All right, our first cases, we have greater than or equal to, or less than or equal to. So we'll start with the greater than or equal to, case one. To solve this, it's going to be just like an equal sign, now with the inequalities. You're going to have the absolute value is isolated, already isolated. So then you break it, you split it up, or you write two inequalities. You have x, one of the inequalities is exactly the way you see it, without the absolute value. The other inequality is x, so whatever's underneath the absolute value, inside the absolute value. Switch the inequality, so switch from greater than to less than or equal to, and then it's always multiply the right side by -1. So when you multiply by -1, that's when you switch the inequality. So switch the inequality and you switch the sign. Now graphing these, we have x is greater than 7 or equal to is filled in circle. Let me do this in black. So black at 7 and then greater than to the right. Now we'll do the red at -7 and it's less than, equal to is a filled in circle to the left. Inequality notation. Now let's talk about each one of these graphs. So I'm going to talk about the first one from left to right. So -7. How far left is this arrow going to go? It's going to go left forever. The number line is going to go to negative, really big numbers, to negative infinity. And it's going to go all the way to -7. The inequality notation to write this is negative infinity is less than x, less than or equal to -7. Equal to because it's filled in. There's a point there. Then the black line, we're going to start at 7, and then it goes to the right forever. Goes to the right forever and ever to the right. Those are positive numbers, so that's infinity. So it's going to go from 7, it's going to start, and it's going to go to the right forever. So it's going to be the least number is 7, x, and greater than to infinity is the biggest number. And it's equal to at 7 because it's a point, there's a point there. Now interval notation, this is what we're going to transition to, is we actually have negative infinity to -7. And let me explain my parentheses versus bracket. So infinity is not equal to, so the parenthesis means not equal to, or a bracket means equal to. So when we work with the black line, we're going from 7, which is a filled in circle, and that's equal to the right forever to infinity. And then it's not equal to, you can never equal infinity. All right, let's work with case number 2. So we have absolute value is isolated, and then we are going to write one of the inequalities exactly without the absolute value. Our second inequality is going to be x, and we're going to flip the sign, switch the sign, and multiply the right side by -1. So let's look at our problem. We have x is less than 7, so 7's here, and it's an open circle because it's not equal to. That's at 6. What am I doing? 7. There we go. And it's less than, so it's to the left. And then -7, open circle, and it's greater than to the right. Well, they're pointed towards each other, so it's in between. So to the right, to the left. And then now our inequality notation is from -7 is the smallest number, x, and the biggest number is +7. So that is our inequality notation. Let me rewrite this again a little bit better. So -7 less than x, which is less than 7. Interval notation, they're not equal to, so parentheses for both. All right, let's work through number 1 here. Number 1, so we have to isolate the absolute value, already isolated. Now let's make this two inequalities. So we have the first inequality is x plus 2. Write it down exactly how you see it without the absolute value. And the second inequality is going to be x plus 2, switch the inequality to less than, and multiply the right side by -1. By -1. Let's solve each inequality. So just subtract 2. And then let's graph it. So x is greater than or equal to 2. Greater than or equal to is filled in circle, and greater than is to the right. Now let's solve the next problem. Let me do this in a different color. So subtract 2, subtract 2. X is less than or equal to, we subtracted so we don't switch to inequality. Less than or equal to -6. Equal to -6, and less than, numbers that are smaller, is to the left. So how far left is this going to go? It's going to go to -infinity, and then how far right? To -6. And on this other number, from 2, the other part of the inequality, and it's going to go to the right to infinity. So inequality notation, we're going to write the left side, -infinity is the smallest number, and it's never going to be equal to a -infinity or infinity, and it's going to be equal to -6. Or we have 2, so the right side here, and it's equal to, that's the smallest number, x, which is less than infinity. Interval notation, I think, is a little bit easier. We have -infinity, it's not equal to, so it's parenthesis, and then -6, and then bracket for equal to. And then we have 2, and it's equal to infinity, and then parenthesis, because it's not equal to. No equal to here. All right, so that's number 1. Let's look at number 2. Number 2 now, we need to isolate the absolute value first. So we need to subtract 6. And that's, we only subtracted, so we do not multiply or divide by a negative, so that's 39. Now the absolute value is isolated, so let's make this 2 equations. So 6x plus 9 less than or equal to 39, and 6x plus 9, so you notice that it's always the same, is greater than or equal to -39. So I switched inequality, switched the sign from positive to negative. And let's solve each. So -9, -9. 6x is less than or equal to 30. Divide by 6, divide by 6. We get x is less than or equal to 5. Let's graph that. So on 5, less than or equal to, less than is to the left. And now let's look at this next inequality. So we'll subtract 9, so it's the same steps as the last inequality. We subtracted, so that's going to be -48. So at -8, we put a closed circle, and then to the right. They're pointed towards each other. When they're pointed towards each other, that means it's going to be shaded in between. That's where they overlap. So those are all our solutions, including the points at -8 and -5. So inequality notation, this one's a little more straightforward. Start at -8, because that's where this point is, and it is going to go to 5. So that's your inequality notation. But I did forget something. They're filled in circles, so they got to be equals. Interval notation, so why did I put -infinity? Oh my gosh. Sorry guys, it's a Friday. It should be -8. My goodness. Oh my gosh, I almost did it again. -8. So -8, it is equal to, so bracket, to 5. Bracket. Alright, last problem. We have operations. We have multiplication of the 3, and we have addition. So you have to do the reverse order of operation. We are adding 9, so we have to, the 9 is positive, so we subtract 9 first. We are isolating the absolute value here. Divide by 3, divide by 3. We get the absolute value is finally isolated. So it's 10x minus 7 greater than or equal to 27. So now we have 2 equations from this. The absolute value, once it's isolated, we make 2 equations. So 10x minus 7 is greater than or equal to 27, then it's 10x minus 7, and it's less than or equal to a negative 27. Let's solve both of these inequalities. Divide by 10, divide by 10. We got a fraction, that's okay. So that's greater than or equal to, and we divided by a positive, so we do not switch to inequality, and that's 17/5 when you divide numerator and denominator by 2. 17/5 is 5 goes into 17 3 times, so it's going to be a little over 3 and just under a half, so that's going to be in here, and it's equal to, so a solid dot, and then greater than is to the right. Now let's solve this other inequality. So add 7. We get did not multiply or divide by any negatives, so we don't switch to inequality. Divide by 10, divide by 10. And the x is less than or equal to negative 2. So negative 2. And to the left, less than is left. Those are numbers that are less than. So how far left does that go? It keeps on going to negative infinity. So our inequality notation for this is negative infinity. It's less than x, that's the smallest number, which is less than or equal to, because it's equal to negative 2, to negative 2. And then for a line on the right, that's 17/5. So it's going to be 17/5 is the smallest number. It's less than, it's the smallest number, so it's less than or equal to x, which is less than, and that's going to go to the right forever to infinity. So those are inequality notation. Now interval notation is going to be negative infinity. Let me do this in blue. So negative infinity to negative 2, and bracket around the negative 2 because it's equal to. And now the inequality notation that we have here in black, let's make that, it's negative or 17/5, and it's bracket because it's equal to infinity. Close it out. All right, on the special cases quick. So special cases, always think about absolute value when it's isolated. If it equals a negative number, you got to think about absolute value of anything is always positive. Is positive a positive number? So that's always a positive number. Oh my gosh. Whatever comes out of it is always going to be positive. And is a positive going to be greater than or equal to a negative number, like negative 5? Yes, it always will be, always true, which means infinite solutions are all real numbers, either one. And there's actually, for all real numbers, there's a fancy R that we can write that stands for all real numbers. Now with B, let's solve this quick because it's not isolated, so we're going to subtract 4 first. And then divide by negative 2. Remember, anytime you multiply or divide by a negative, that is going to switch the inequality. So that becomes a less than. Now let's take a look at this. So the absolute value of x plus 3, that's always going to be remember, that's going to be a positive number that comes out of it. No matter what's inside, after you take the absolute value of it, it's going to be a positive number. Can a positive number be less than a negative? No, a positive number never can be less than, so that's not true. If it's not true, it's not ever true, so that's a no solution. So less than a negative number, when the absolute value is isolated, is always a no solution. Otherwise, it's infinite solutions, or you could say all real numbers if it is greater than